Good evening. Today we are going to cover a technique that we have developed which we call digital dipstick and the 5 A's, the first of the 5 A's. Just as I had become global CIO of Cognizant, we had this situation on our hands. We had just rolled out this system called the capital appropriation request. Whenever you wanted to acquire IT assets like laptops and so on, you had to fill this form. And the system was quite complicated to enter this data. There were many fields. It was a header and detail kind of layout. We soon had a mutiny on our hands because the previous version of this form was in Excel and it was very easy to use. So our users said, we don't want this system, please give us the Excel back. Because it was taking some 30 to 40 minutes to fill each car. When we talked to the finance department, they rightfully pointed out that because capital appropriations are scrutinized heavily, for compliance reasons, we had to retain all the fields. Now, in the new role that I had taken over, I had set this extreme objective for our team, that we should do things that create 500% productivity gain, and there should be no training or change management required to use our apps. Obviously, this car system was flying against this objective. Why I like this example is because the team took this upon themselves and they did something very interesting. They went into the data and looked at it and it revealed something very interesting. It turns out 60 to 70% of the car requests were single line cars. Now, armed with that knowledge, and once you have that knowledge, you would also design something similar, which they call the quick car, which use the wizard-like layout. For the 5 most frequently requested item, you click that, it will fill the complex form on the back end and send it into the workflow that was orchestrated by the car system. Problem was solved. This took all of 20 seconds for our users and they loved it. So this is how we met that extreme objective. Now the question is, why did the car system get designed like that? Now I talked about the trim tab invention of Buckminster Fuller in the extreme pivot session. Why was the rudder so big? And if you look at the retail world, when they rolled out checkout counters, the express checkout counter was not there. Somebody observed that why should I stand in line behind somebody buying 3 cart full of stuff when I need to buy just 3 items, right? So that's how the express checkout came about. But why didn't it all start when the checkout counters started? So that brings us to a design anti-fractal, as we call it, which is symmetry. Even if I look back at the systems that I had designed, especially of the ones that were converted from paper forms or Excel or PDF forms into systems, this symmetry principle was there. So the rudder was proportionate in size to the size of the ship itself. That's how the rudder became so big. Express checkout, all the counters looking similar, that is symmetry. The car has to handle all kinds of car. So the symmetry is an anti-pattern that exists in our head. So to counter that, we can use asymmetric design principle. Trim tab is using the asymmetric design principle. Express checkout is an asymmetric design. Quick car is an asymmetric design. So we can use this principle to design new kinds of digital transformations. So let me give you a couple more examples. One of our mentees was working on a margin call system for a large bank, and customers were complaining that there was a long wait time for the reports. When we analyzed the data, we found that securities of type A and B had no exceptions at all, and they formed 90% of the quantity of the trades. So with this knowledge, we were able to create a separate path for the A and B securities and deliver that part of the report quickly to the client while we process the exceptions on C, D, and E manually. That had a huge impact on the customer experience. In my other job in CMI Algolabs, we had a client who came to us because they wanted to automate exception processing in claims, which all the claims they were processing manually and exceptions proved to be slowing them down. So they came to us. We did a basic clustering, which is a k-means clustering algorithm on the data, and we found 60% of the claims were 0 exceptions, which means they were straight away approved. So all we had to do was to create an ML algorithm that would indicate to the auditors whether they should manually audit something or not. So the ones that had 0 exceptions, we were able to learn the pattern and slot them into the audit no category, and that by itself improved the productivity by 50%. So I want to take another real example that I've been working on in the last few days. Amazon Go, you might have all come across, where they've eliminated the checkout counters, and it is quite a brilliant piece of technology, and I want to show you a quick demo of that.
Gonna enter the store, so where do I tap it?
Right here?
Right here? Great, thank you so much. Appreciate it. Gonna grab one of these. Chicken banh mi sandwich? Sure. And it's that easy?
Yeah.
You just walk out, that's it?
Right there.
So I left Amazon Go about 10 minutes ago. And they got it exactly right.
So this turns out that Amazon is spending about $1 million per store just on the hardware, and $5 million maybe for the entire software and stuff. Now I was inspired by that, and I wanted to see if I could do something with this using digital. So I set myself an extreme objective of doing a $5 checkout using digital technologies. Now in this session you learned about asymmetry, so I apply asymmetry and I want to create an express checkout for just $5. I went yesterday to the supermarket and I bought these 5 things, packets of rusk and some milk for my family. Now in the demo, I am going to show you how I use Google Vision API to automatically recognize these. I am in the Google Vision API screen. I am going to add the image of the items that I bought yesterday. It takes a few seconds to process. And you can see that it recognized the packaged goods. It's a bag packaged good. As I said, milk is packaged in a plastic packet in India. It has recognized the labels. Because it's an Indian word, it didn't quite recognize the logo of this milk packet, but it got it reasonably right. Even then, in the text recognition, it got the correct word, Orokia, very well. And it's a milk, the contents, type of milk, the Britannia toasted bread, everything it has got reasonably accurately. And the beauty is, I have not done any training for this algorithm. If I train it, it can actually do this whole thing better. Now this whole thing is available as a JSON, so I could do this using a simple Python program and do the whole thing. So this is how simple a $5 express checkout is, right? So this is the power of digital technology today. A small superstore with a programmer working for a week or two could just create this, right? It is that powerful. Now if I did a zoom out on this using depth sensing cameras, hyperspectral imaging cameras, now the LiDAR technology which the self-driving cars use is now available in your iPad Pro, and I am told it's coming into your iPhone also. So you could build a new kind of checkout system that scans all the products in your carts at once without having to scan one by one. So if you did something like that, you could dramatically transform the checkout experience, which is obviously the slowest part. Nobody likes to stand in the queue. Now you could drive the technology further into the aisles and do things as they pick up from the aisle, like what Amazon Go is doing. So we could do things inexpensively. This is the real power of digital technology. I hope you enjoyed my $5 express checkout and this aspect of asymmetric design. Maybe you can all apply it on your systems.